Hello and welcome to the C++ and C# Open Office Hours for May 21st, 2012. I'll be here and Gavin will be here.
Hurrah!
Yay.
And almost no one else.
Yeah, I guess we're just going to hang out for a little bit and see what people are going to be asking about. In fact, I'm going to go ahead and just pause the video until a question comes in because of,
Yeah.
Okay, we're back. So we got a question. C++, when you point a pointer to a custom type, do you need to use the address of? Well, it depends.
And it says, e.g., my pointer my type equals address of my type instance.
That syntax will only be valid for a pointer. So let me go ahead and talk about this real fast. Basically, the rules about using a pointer are the same for using a built-in type or a custom type. There's no difference between the semantics of either. When you have a function that takes in a pointer to something, you have to invoke it. Now, basically, I have to invoke this function with something that is convertible to an integer pointer. One of those things would be the address of my number. The address of my number is convertible to a pointer of int. Just as if I had done this, my number pointer equals address of my number. Now I can invoke my function given a my number pointer. So you'll notice that I don't have to use the address of operator here because I'm passing in a pointer directly, but I have to use the address of operator here because I'm passing in a straight object. But if I had another...
Well, and functionally you're doing the same thing with both of those. It's just that in one you've oh dear, words and things. You've somethinged out the variable. Oh wow.
Aliased out the variable.
Aliased out the variable. Well, that word just went.
And then...
But yeah, you're doing the same thing, but you've aliased out the variable into, or the pointer into its own variable.
Well, notice also that inside of, I have two functions now, my other function and my function, they both take in an int pointer. Notice how I'm able to invoke my other function given an int pointer, because an int pointer is assignable to an int pointer. Can you do int ptr equals 10? You cannot do this, because on the left-hand side you have a pointer to an integer, on the right-hand side you have an integer literal. Nor would you be allowed to do this. This doesn't make any sense because the address of the literal 10 has no address, so there's no way to use an address of pointer. Now what you can do is you can explicitly cast a number to an integer pointer, but what you'll have is something that you wouldn't want. What you'll have is a pointer that's pointing to the 10th address in my memory, which isn't what you want.
In order to do what you were asking, Chris, you would do int my number, but you would essentially do lines 17 and 18.
Think about it this way. The ampersand symbol always has to match up when you're converting a non-pointer type into its corresponding pointer type. So given that int pointer, my int pointer, is an int pointer type, we must use the address of operator on not a constant, but on a variable that is of type int.
If you actually remember to read the ampersand as the address of, it should make more sense to you. Because, my function takes in the address of my number, because the address of my number is a pointer. Does that make sense, Chris? he's not saying anything.
Okay, no, he said something about BuzzNet.
Oh.
Alrighty, so I'm going to go ahead and pause the video again, wait for more questions. Alright, and we're back, so let's go ahead and talk about console.background color.
Console.background color equals new color.
No, it's actually
Doesn't work.
console.background
And they have
color.
really, really, really stupid names. Sorry, carry on. These colors have really, really dumb names.
I think Dual Amp's getting bored.
Pardon that?
Anyway, console.background color, you can set to any one of these predefined enumeration values. So I can say background color is cyan, and then I can say console.foreground color equals console color dot black. And after setting those, I can say right line hello world. And you get this. Let's actually make this a little bit cooler.
By not using cyan. Hi, Florum.
I want my resharper.
This is OpenOffice. You could have quite easily done it in ReSharper. You hear that one? That one's about 200 feet above me.
No, I want these color values, I guess. That's what I'm going to call these guys. Anyway, I'm just showing you guys a fun little thing you could do. Oh, come on, really? Oh, what are you complaining about? Oh, great. I hate naming things. I can't think. It's too early in the morning.
One
Okay.
advantage of using English spelling all the time. I never ran into that.
So basically what I've done here is I've created an enum called colors, which has prompt, input, and menu. And now I have this private class that can store up to 2 console colors. And I'm creating a private static read-only dictionary that associates one of my color enums to multiple console colors. So now what I can do is I can write a nice little reusable class where I can have associate a foreground color and a background color to each one of my custom enum values. So I can say I want my input to be foreground color to be white and my background color to be black. And then I want my menu to have a foreground of white and a background of dark blue. And then I want my prompt to be purple or cyan or something like that. Now inside of my console display class, what I can do is I can go ahead and cache the existing console color into temporary variables. So I can do that and then that. And then I can say, okay, now let's go ahead and grab my color values equals values at color. So now I can go ahead and change the console to whatever I pulled out of here. So I'm actually going to promote these. I'm actually going to just go ahead and say public void switch that says console.foreground color equals foreground color, console.background color equals background color. So now I can say, instead of doing this, I can do color values, old values. And so I can say old values equals new color values, console.foreground color, console.background. So I'm caching the old values, then I'm grabbing the new values, and then I'm having them switch to that, and then I'm going to have a public void pop method that takes the old values and switches it to them. So now inside of the constructor, it switches to my new values, and then when I invoke the pop method, it switches back to my old values. So now I can say something like var display equals new console display, pass in colors dot menu, and then say console right line, hey there, this is a menu. Then I can say display dot pop, and I can say display equals new console display colors dot prompt console right line enter name, something like that. Then I can say display dot pop, and now I can say display equals new console display colors dot input, and I can say var name equals console read line, and then display dot pop. So now I have a nice little reusable way to I meant right, not right line, to have multiple little colors. Now using iDisposable will allow.
I was going to say, is there not a destructor available to you?
No. The only deterministic destruction you get in .NET is by implementing the iDisposable interface and using a using statement.
Right. But you could, I mean, you could, if you're doing this a lot, you could valid, that would be a valid approach to doing it.
Yes, and also a more valid approach would be using lambdas and delegates. But of course, I'm not going to do either of those things. The last thing that you might think that's interesting is, for example, on one of my output methods, on in my rendition of the RPG, I have a class called like output or something, and then it has a public static void write full line method. And what this will do is, the first thing it'll do is it'll split the input into multiple lines, or split the output into multiple lines. So I can say var lines equals output dot split on new line. And then I loop through each line. I do something really cool. I loop, say, for each var line in lines, and then I say console.write line, and then I fill the rest up with spaces. And you'll notice a really interesting thing we get from this. So var equals 0, I smaller than console.buffer width minus line.length I++, and now I can say console.write space. And watch what happens when I use this method now. So instead of using console.writeLine, I can say output.write full line. And when I run this code, you'll notice the background of this text extends all the way to the end.
Which makes sense. Really?
Yeah.
But that is a cool little thing. It's just frustrating that it's such a limited palette of horrible colours.
Yeah.
But hey, there was while we're on the subject of like playing with the console, as it were, positioning and size of console, are they settable in code?
The size is the size settable?
I think they all are.
Oh yeah, it is.
But it's a character size.
Yeah, and also notice that it doesn't automatically increase the width of my window. It just gives me this scroll bar.
Yeah, it's sized in characters, by the way. You will find that the numbers you end up entering are considerably less than what you'd expected.
But if I say console.window width equals that, and then buffer width equals that, I should probably do it the other way around. Increase the buffer size and then the window size. Then you'll notice I get a nice little sized window. By the way, doing this in C++ is a nightmare. Would iDisposable mean you wouldn't have to use the pop method? Yeah, I'm not going to explain this because we're going to be talking about this a lot later, but I'll just show you what I mean. If I implement the iDisposable interface, and instead of calling this method pop, called it dispose, now what I can do is I can wrap every one of my instances of using the console display in a using statement. In fact, I don't even have to alias that to a variable. I can say using new console display, and then wrap this in a block. And then because the block will automatically call the dispose method at the end of it, we'll get the behavior that we want. I don't recommend... See, here's the thing. I typically don't recommend using this sort of syntax, but when you aren't allowed to by my own limitations to how the class is going to use delegates and lambdas, then this is the only way to cleanly perform the same behavior. Okay.
That's all the questions we've had so far.
I mean, I can just show people what I mean by when I say using delegates and lambdas, just to
kill the time. Do it.
Just to kill the
time. For anyone who's interested. Yeah.
I'd probably have output, and then I'd probably have public static void with color action, and then I would have var display equals new console display, pass in color, invoke the action, and then say display.dispose, or pop in this case, which it should be. And then instead of doing this code, now I can do output.withColor, colors.menu, and then pass in a single line lambda, like that. And then do that here. So colors.prompt, and then pull over the prompt, which actually is going to be just console.write in this case. And then the input is going to have to be a multi-line lambda. So I'm going to say using with console.input, pass in a multi-line lambda, and then terminate. And I get the same result. This would be my final, or close to my final solution. But again, I just tossed that in there for people who are bored because there aren't any questions. This kind of syntax will be explained in full in later classes, so it is something to look forward to, I suppose. Alright, I'm going to go ahead and pause the video again. Or we did have just a question. I would need help to understand how properly implemented the move room command. Could you look at my code? Sure. Hello.
Hey, David.
Hey.
Okay. Okay. Right now this is working, but the command is not properly implemented.
Okay.
Because I did everything inside the start game command.
Okay, so that's where you...
So everything is happening here. And I could not get... so I typed something that I placed in command like this almost everywhere. This is what you show on your code.
Yeah.
But I could not get it.
Well, basically, to the start game Um, and then that's the start game command. Yeah, you don't necessarily have to take it, but what you're going to want to do is
Nelson, you keep cutting out, sir.
oh, hello?
Yeah.
Yeah.
I accidentally hit my mute button again.
Wow.
Yeah, so
Start again.
yeah, okay, so if you keep everything in this class the way it is, including your instantiation of your game objects, but if you scroll down a little bit, what you're going to want to do is once you get the game started, instead of having that while loop, you're going to want to take advantage of the looping mechanism you already have in your state machine. So you're going to want to, the first state you're going to want to switch to after you start the game is going to be the the room command or the room state. You're going to want to transition into the room state. Not the command that moves you to the room state, but the state for the room. Yeah, that guy. You're going to want to switch into this guy, passing in the engine, the last room state, and the I room. If you try to, well, if you jump back into your new game state, or I think it's your start game command, whichever one that you were just at with all your code. You might want to start just by commenting out all of your existing code and then trying to get that exact same behavior given transitioning to other states. So if you jump into the...
Can you say start game command?
Yeah, start game
Not
command.
start game state.
So if you comment out everything between lines 54 and 54 and scroll down to the end of that method, and then you're going to want to bring all this code into another state. So if you scroll up, the first thing you're going to want to do after you start the game is you're going to want to transition into the room state for the first room that the player is in. So that would be...
I need to call the room state here.
Yeah, you need to get that to be activated as the current active state. So something like I don't know where your state manager is being
like I have here.
Yeah, you would return a new switch state command. Well, actually, yeah, into again, this is one potential way to write the system, but to just get you going with using the other classes, you could go ahead and switch over to that. You can either do that. I mean, you are in a command already, and because you're in a command can't return another command. But what you could do is you could do game dot, or not game dot, but engine dot, which it doesn't look like this class has a reference to your engine. So the first bit of refactoring you're going to have to do is pass an engine into this class when you instantiate it.
Okay.
Via the constructor. You don't have to worry about passing in the player name. You can grab that input inside of this command if you want, but you will definitely need an engine in the constructor because the engine has to be threaded through.
I need to do that?
Yeah, you're going to need that reference from your command and passed into the constructor of your new game command.
The new game, this one?
Or start game command, sorry. I'm getting... There you go. And then, yeah, paste that constructor in so you have a... And you're going to want to do switch state directly here, and then you're going to instantiate a new room state. and pass it into that method, because that's the transition that you want to go through. Be sure to throw in some parentheses. You're gonna need some parentheses around in the.
Is it
Well, in the parentheses, the switch state method is a method, so you're going to have to wrap your new room state instantiation inside of parentheses themselves.
Put an open parenthesis at the end of the word switch state.
just
No, in
to
where you are,
understand?
where you were in code.
Is it the same way I did it here?
No. In this case, if you look at this method returns a new command. This method does not. This method, you're going to have to reach into the engine itself to switch the state. So you're going to want to say engine.switchState and then open up a parenthesis after switch state.
No, you've got engine.switchState written already on that line.
Okay.
Add a parenthesis after it, opening.
After it?
After switch state. Yeah, there.
Yep.
Because you can see switch state takes in an I state.
Okay.
It's a method.
So then inside of those, you'll want to instantiate a new room state. Now, if you open
So I have to remove this one?
yeah, you can just delete that. Now, if you open up a parenthesis on your room state, you'll get a list of, if you open up a parenthesis immediately after the token room state, you'll get a list of things that you have to pass in. So you're going to have to pass in, if you move your mouse, your keyboard cursor one over, you're going to have to pass in a engine, a last state, and a room. Although the last state shouldn't, isn't a requirement for this particular state, but you're going to have to pass in the engine at the very least into it. You're going to have to thread that object all the way through your program. So you're going to want to pass in your engine object that you have a reference to. Your field, the underscore engine. And then, comma, you need a last room state, which you don't have at the moment. I wouldn't worry about that parameter. I would actually recommend deleting that parameter out of the constructor of room state. But instead, yeah, so go jump into room state and just nuke that parameter.
This one?
Yeah, it's not going to be necessary for at least. I mean, you can add it back if you need it, but I'm just trying to. Yeah, and now if you jump back to start game, so now the last parameter you need to pass in is the room you want the player to be in, which is going to be game.player.currentRoom. So that will switch the entire state of the, hold on, best overload. Could you, on your error list down on the bottom, could you scroll one down?
Does your room actually implement the iRoom?
That's what I'm thinking, but cannot convert from room to iRoom.
No, it doesn't.
So on that last error you're getting on your error list is saying that your room object that current room is doesn't implement iRoom. So it's not compatible as a parameter. So to fix that, you're going to have to.
Is it on this one?
Yeah, it doesn't implement.
No, it'll be on the room itself.
Yeah, the room class. I think that's in your main
room state. Sorry,
yep,
room.
That one.
Yeah.
You're going to want to make sure that this implements iRoom and iGameObject, because otherwise this object isn't going to be convertible.
You're already implementing iGameObject. Put a comma and then iRoom next to it.
On line 9.
On line 9.
You need to make this convertible into an iRoom. So if you do a comma after iGameObject and do iRoom, then that error in your other code should go away. Sweet. There is a few things that you're going to have to quickly fix as well. I noticed that if you scroll up to your constructor in your start game command, you have the engine field, but you never assign it to anything. So if you're going to want to go ahead and create a constructor for this state or for this command that takes in an engine.
Okay, the same way I did it here.
Yep. And then just delete the I state or the last state out of, so just paste it there, change the name to engine, delete the last state, and you should be good. Or change the name to start game command. Sorry. So that it becomes a constructor. And then after nuking line 18, now you should have an error. The error that you should have is when you instantiate start game command, you're going to have to change that. So I would double...
Where?
If you look at your error list, a new error appeared on the bottom of your error list. And if you double click on that, that'll take you to where the code that you just made not work. But you can make it work. How would you go about making that code work?
Just passing the engine.
Mm-hmm. Sweet. So you have two more errors. Jump down to that one. I think you can just safely comment out that bit of code right there.
This one?
Yeah, you're not going to necessarily want a back command for your room state anyway, because you're going to want people to have to go to a room. So I wouldn't even line 65 through 68. I wouldn't even worry about keeping. Because you're not the back command within the game itself, you typically don't type in back to move back. You typically type in move, and then you type in a room name.
Okay.
So now you have one last.
So all this I can comment.
Yeah, I wouldn't worry about any of that. Because the great thing about having the separation of states is that each state can do fundamentally different things. They don't all need to present the same menu. So now if you double click on that last error in your error list, it looks like you have a typo somewhere. Scroll up. It looks like you're missing a...
It'll be in the comments. It'll be because of the comments, and there'll be a... Go to the very end and type a closing curly brace. No, go to the very end and type a closing curly brace. Huh.
Yeah, something with the comments. Yeah, keep your keyboard cursor right there. Or do that. There you go. Okay, so now if you run your code, you should be jumping into your room state now. When you run your code and try to start a game, it should jump into your room state and see what happens. I think it might also be useful. What's that? Oh yeah, because you made room implement iRoom, you're going to have to make sure that you have the getConnectedRoom method implemented in your room class, which I think I saw you have. You had it commented out under, if you scroll down a little bit. I think I vaguely remember you having a getConnectedRoom. Yeah, you do, right on line 41 through 45. I wouldn't worry about implementing this yet. I would just have it return null. If you have it return null, you'll get rid of the compiler error. So you'll be able to test your code right now and then fix that later. Okay, so now if you hit F5, that should... Sweet, so... Sweet. So now you've successfully jumped into the room state. It might be good right now to...
I think it'd be a good idea, Nelson, if you were to
whiteboard.
Whiteboard out
Yeah.
the logic of what order things happen, because this is exactly the same sort of. It's a question of the logic of what's going on, leading you to coding problems, David, rather than. Do you see what I mean?
Yeah.
And it's very similar to a problem I was having with something else the other day as well. And it's just knowing what's supposed to happen in what order, and what triggers what.
Yeah.
Is the key to, because at the end of the day, this isn't a class about how to make a grid-based text adventure game. It's about using that to explain these principles, so that you can then, if you can get a grasp of the logic that's happening here between the states and the commands
Yeah,
and the entities that are in the game, whether they're rooms or giraffes or ponies. Oh, you'll need to hit Shift F5 to get out of debug mode, by the way.
Yeah, your code still will need some additional work, and I'm more than willing to help. But I do want to jump back and do a quick diagram of the logic of the system, because I think that'll help.
Okay.
So let me go ahead and jump back to me, and I'll get my whiteboard up.
Okay.
I'm just going to mute you for a little bit, David.
Okay, so basically the sort of architecture that we have is we have this concept of a state and a command. And the way at least my system works is I start with a main menu state. This is the state that is currently active when you start the game. Now, when you type in, so input, start, the main menu state pushes a start game command. And you already have this with your code. Now, the start game command transitions this current state into a room state. And the room state will display to the user the description of the room, the connected rooms, and it'll allow them to type in a move command. And the move text, so move room 2, for example, would be text that the user inserted. This would transition into a move room command. Which the move room command will switch to another room state. The other room state will be, it'll pass in the room that you wanted, so in this case room 2, into the constructor of the room state. And the room state will continuously loop. That being said, this architecture gains us some flexibility because, for example, you can have an inventory state. Which shows the current player's inventory, which could be accessed by typing in the input inventory, which transitions into the inventory state. And then the inventory state can allow the user to work with his inventory over and over and over again by processing additional commands. And then when the user types in back or something like that, then the inventory state will jump all the way out back into the room state that was active. So you have this concept of states and commands. And the states are responsible for the user interface. The commands are responsible for not having proper colors on my palette.
Because you started off with a white background. But it's easy to see from it drawn out like this. You can immediately start filling in some of what each class's constructor needs handing to it. Because you can see there, main menu state, start game command puts you in the room state. So the start game command needs to know, well, at the very least, what room to put you in. So that will have to take in some form of room, or in, yeah, I'm going to be more specific than that, but. Similarly, the inventory state, in fact, any state where you want to be able to go back to the preceding state, will need to be a state that takes in a last state or similar parameter in order to have something to go back to.
Right. So in this case, we have. So I'm going to go ahead and point out. Actually, I'm going to use a different color now. I'm going to live on the edge here.
Dude.
Because this is user input. Right here. This is a command. I'm just going to do cmd obj. This is a command object. This is a state. And this is a state. This is user input. This is a cmd obj. This is a CTOR parameter, or a constructor parameter, room2 is. And then again, this is the typing in inventory is a user input, as well as this, user input. And this is a state. So this diagram represents quite a few different aspects of the program. We have a state that displays a UI. Then the UI reads in user input and returns a command. The command can do whatever it wants. But in the case of a start game command, what the start game command is going to do is it's going to instantiate the game objects, and then it's going to transition into the first room state. Once you're in the room state, at that point, you have a few different options. You can do quite a few things. You could even type in load. So if I switched over, let me get black on my palette again. So if we have a load state, the load state is accessible by typing in load from the main menu, which will transition into the load state, or by typing in load from a room state. And that will get back into the load state. And so that's how the states are really reusable, because we can jump in to any state from any state at any point.
And again, there you can see that the load state is obviously going to need to take the information in for loading. I mean, I know that saying that out loud sounds facetious, but I'm not trying to be. Drawing it out can be really helpful just in terms of concretely getting hold of what actual logic is needed and what is... Because particularly once you start getting into many states and many commands, it gets very easy to copy a load of, sort of copy and paste a load, and then just gradually end up with bits and pieces that you don't really need, particularly with like constructor parameters. Mm-hmm. You can start copying around constructors of things and going, oh, well, I've needed that for this state, so I need something similar for this new state. But actually not really planning out the logic properly and ending up either with just random things being passed around for no good reason, which is an optimization issue as much as anything, or just getting utterly befuddled in lots of code that you actually don't need to be there, and if it wasn't there, it would be easier to see what was going on.
Yeah. With your last state, your room state didn't need a last state parameter, because the room state never transitions back into the last state. The only way to transition a room state into anything else would be to type in move or inventory or something else that has to do with the actual game logic.
Incidentally, it's probably a good idea to hit print screen now if anyone's in need of this information. But David, does that make sense?
Yeah, it's a little bit more clear. I'm still having difficulty with the syntax also, how to call properly all the command and everything.
Nelson?
Hello?
Are you still there?
Maybe. I think so. Can you hear me?
Yeah, but you weren't saying anything, so...
I might not have heard a question then, because I didn't...
No, there weren't any. There was just everything stopped.
Oh.
Yeah, but the logic is more clear now. But yeah, I'm gonna have to practice coding more.
Yeah, and yeah, but the biggest things to really pay attention to, the most important aspect of either a state or a command is the, and I'm going to... The constructor arguments should, like Gavin said, will lead you to know what the responsibilities of a particular state are at any given time. They're really important, especially when reading object-oriented code. You should be able to gather the responsibility of a particular class given nothing but the list of parameters it takes into the constructor. Anyway, so yeah, I'm going to go ahead and pause the video again. Go ahead and resume, and let's go ahead and jump back and see what's going on. So your room connection class, where is that supposed to be defined at? I think you have a typo. That would be my first guess. Go ahead and try to copy the class name on line 6. Just copy it, jump back to iRoom, and paste it. Okay, now if you try to do a Control-Shift-B.
Nelson, he's just missing the using.
Oh, right. I'm sorry, I'm used to ReSharper.
Wow.
Are you sure? Actually?
Yes.
Okay.
It's in a different namespace.
Go ahead and... you can actually get Visual Studio to do this for you automatically. If you put your keyboard cursor onto the squiggles on line 16...
You'll need to delete what you just did on line 3.
Yeah, nuke line 3. Now go to line 15. Put your keyboard cursor right there. Now hit Control Dot. And say Enter. Or just that. Sweet.
And Dave, for future reference, if you look at, that's what the error was telling you. Are you missing a using directive or an assembly reference? You were missing a using directive.
Yeah, and you can get Visual Studio to do it. The reason I didn't pick up on that is because I'm used to ReSharper having that little pop-up.
Yeah, I was just going to say, and then the reason I spotted that, if you go back to where room connection is, well, the way to find that out is if you go to room connection itself, the CS file, just click on the tab at the top. No, just the tab, the second tab across, roomconnection.cs. Up, before your code, about a centimetre above where it says using system. Above. Up. No, just move. Oh, can I? There we go. Right. You can see there, namespace, danim3d homeworked4.gameObjects on line 4. That's the namespace that room connection is in. That's what you were, and if you go back to your iRoom again, you'll see that that wasn't there, which was causing the error. Because if you go back to the iRoom, can you hear me? Hello?
Hello? I can hear you.
Can you hear me, Nelson?
Yes.
Sorry, I was saying go back to the iRoom, David. Yeah. That's the using it just brought in on line 3, is the namespace that room connection is in.
Okay.
And yes.
But could I have just removed that here?
Well, it depends where you want whether you want that to be in the game objects namespace or in the homework 4 namespace. In fact, you'd still need it because this iRoom is in the abstracts namespace.
Okay.
The name, do you see? And it's not a question of moving things into other namespaces in order to not have to bring in the using. That's what usings are for, is using something that's in a different namespace.
Right.
And again, because you can see where the squiggly is on room, in fact, if you double-click on that error message, it will take you there. And if you put your cursor there, your actual input cursor, just, yeah. It's not there. How silly. What if you put it right at the beginning of that word?
Yeah, there's... Nope, there it was first. There you go. Or no, that's just... I think it's... Yeah, that's just... it's just being stupid.
Get resharper. Definitely get resharper.
I can do the same trick?
No.
With
If you go along to the end of the line and add a comma and whatever it was telling you it was missing, oh no, it doesn't implement the member. Sorry, yes, don't do that. You'll need to implement the missing method, because that's what implementing a method, implementing an interface is. It's you're saying it's forcing you to implement whatever's on the. No.
No, it's not that.
It's a different problem. Read the error message. It says, does not implement interface member downtree homework for abstract iRoom.connections. Now, on line 9, you're telling it to implement iRoom. That means that it has to implement whatever iRoom tells it to. Now, if you go across to your iRoom CS file, you can see you're saying it's got a name, a description, connections, INU rule of room connection, and an iRoom get connected room. That means all of those have to be implemented in order for room to become an iRoom. That's what interface implementation is for. It's locking you down, saying you have to implement these things in order to call yourself an iRoom. So over here, you haven't implemented a connections method. No, you haven't.
Will be this line.
Close. Now you're going to run into the same error, but you can fix it in the same way. Now think about what the errors... well, there's two errors, but the one on the left you can fix immediately. Because you need to import the room connection type into this file. So if you click on it and then you do Control Dot, you'll be able to have Visual Studio automatically bring in that using for you. So now the final error is saying that you don't have a particular field in this class yet, but you already do actually have this code. It's just commented out. So think about what you would have to add to make this code work.
You could probably bring.
And that's going to require a
well.
recompile before that error will go away.
Okay, what's the dot value here?
Yeah, you need to. Anytime you want to edit stuff after this, you'll need to hit Shift F5 to stop the debugging session.
Yeah, but notice what error you got. You got the connection. The connections is null.
And that's from line 29 not being. It's never being set. You see.
Well, line 29 still needs to. You still need to instantiate your connections field because your connections field is just a reference to a collection. So how would you go about getting your connections field to be a valid reference to an object? See, there's Visual Studio telling you you never assign that reference to anything, so it'll always be null, and whenever you try to use it, you'll always get an exception. So what you're going to need to do is make sure that that object is instantiated.
Okay. How do I instance that?
Did
back in your room class, if you look at your constructor, so your constructor on line 22 is going to be invoked. That bit of code between lines 22 and 25 is going to be invoked every time that your room class is created. Now you're going to want to do an additional thing inside of that constructor. You're going to want to set your connections, which is a reference to a dictionary. You're going to want to assign it to a new instantiation of a dictionary. And the only valid place to do that here is going to be on after line 24 or before line 24. Because otherwise you'll get a null reference exception every time you try to use that field. So if you go ahead and hit enter and add a new line on right there and do connections, and how would you go about instantiating connections on line 24 now?
I'm not sure.
You're going to want to set it to a new instance of an object, or a new instance specifically of a dictionary. So Visual Studio will actually help you do this. If you type in underscore connections and say equals, and then use the new operator, yeah, and then just hit enter because Visual Studio just filled that in for you. And then you're going to have to add parentheses, of course, and a semicolon for the constructor there. Yep. So now if you build, that warning will go away, and the error that you had won't happen anymore. Or at least this particular error won't happen anymore. You might have other problems, but at least that problem will go away.
Okay, now there's nothing. Okay.
So do you see why on line 24 is really important for this?
I'm not sure to understand why it happened on this line 24.
Because your connections object on line 13, it isn't actually an object, it's a reference. The underscore connections field is a reference to another thing. You need to assign that reference to a thing in order for that field to be considered valid. And so you do...
line 13, basically you've just asserted that it exists, but you haven't actually made it exist. That's what you're doing on line 24. Now, you could, and Nelson will have a heart attack, but you could have combined those in both on line 13 and just said private read-only dictionary string room connection connections equals new dictionary string. But that's not good practice. It's better to do it in the constructor.
Yeah.
Okay.
So remember that every time a room is created, every time a room is instantiated by somebody else, your constructor that is now between lines 22 and 26 will be invoked. That code will execute. Actually, here, could you do this? Could you set a breakpoint on line 24? Just click over on...
click over to the left of... No. Click over to the left of the number, the actual line number 24.
Yeah, click on the gutter right there, further to the left. There you go. Now go ahead and run your program. And start a game. Okay, now hover over underscore connections. You're now in the debugger. Hover over underscore connections so you can see its value. In your...
Actually hover your mouse cursor over the word connections on line 24.
Yep. Now Click on that little pin button to the right to get that to pinned. Now drag it somewhere that you can pay attention to it after you pin it. Just get it to be pinned so you can keep. Okay. Now look at it. Look really closely at what you just pinned right now. It says connections. If you click off that, it says connections equals null. Now if you hit F10, that will execute this line of code. Watch what happens to the thing the floating window. You'll notice connections changes. It actually turns into a real object. Before that, it was just a null. It didn't exist. But by newing it up, by instantiating, by using the new operator, you have now made it a valid object that can be acted on. Otherwise, that object would remain to be null, and every time you tried to use it, you would get an error. But now that you've instantiated it, which you can notice now, instead of connections being null, now it's saying connections count equals 0.
Is it the same for any variable or just for object?
It's for all classes.
You'd see the same with ID.
ID is a struct. GUIDs are structs. The ID will actually be, it won't be null. ID will just be an empty blank GUID until you assign it. But for all objects, that's what happens. Here, let me switch over back to my screen, and maybe I can show another example, but with less. And you want to hit either F5 or Shift F5 to get out of that. But let me show another example that doesn't have the weight of the rest of your code around it.
And was it week 5 or week 6 we did this in 101?
I can't
Nelson. I'm sure it was either week 5 or week 6. Somebody will probably be able to tell us in BuzzNet. But it'd be well worth reviewing anything that was covered in the 101. I know they're long videos, but
okay. So if I do this, if I say, oh, my tablet, I'm reaching over my tablet and it keeps on pressing buttons for me. What? Hold on. Let me get this out of the way.
You could just open up the version that's got ReSharper on.
Well, no, it's literally inserting stuff that I don't want it to.
Yeah, I know, but still.
Okay, so...
I was giving you an excuse to open it.
Alrighty. So, David, line 28 will compile. However, this code is not going to run at runtime. If I try to run this code, you'll notice that I get a nice little error, a runtime error, a null reference exception on line 28. This is the code telling me that I'm trying to act upon a reference to an object that hasn't been instantiated yet. If I move line 28 underneath the instantiation, so if I move the instantiation of the room to happen before I act upon that object and I hit F5, you'll notice I get hey. So if I were to step through this on the debugger, we'll notice something interesting. The room starts off as null, meaning acting upon this object in any way is invalid and will cause an error. However, when I execute line 28, you'll notice it turns into a real object. Now I can act upon it. So basically, another way to explain it.
Well, it makes sense, particularly when you put it like that, because, you know, someone who doesn't exist can't say hey.
Right.
They've got to exist before they can say hey to you.
So, something like, oh, come on. There we go. So something like room, or room, stuff, doesn't matter what I call the local variable, equals null. When I say stuff dot hey, here's what happens. The hey method attempts to be invoked on this variable. However, what is this variable set to? It's set to null. Null doesn't exist. So you have your computer's memory. And your memory has a bunch of stuff in it, a bunch of bytes. Null is the absence of being in existence. So here's all the valid bits of memory in your computer, and here's null. Null is way over here. It doesn't have a place. It's not in existence. However, if I were to change this example to where I said stuff equals new room. Here's what, well, I can't do that because this is not C++.
That will break.
If I do stuff equals new room, the new operator will reach into my memory and reserve a place where my room can live. So let's say these 3 bytes are where my room lives now. So my room is now in existence. It is in memory. Now when I say, just deleting my arrows. Now when I say stuff.hey, that rhymed unintentionally. Now when I say stuff.hey, the hey method is being invoked on the stuff reference. Well, what does the stuff reference point to? It no longer points to null. It now knows that it has a place in memory where it can operate on. If it pointed to null, this would throw an exception. So to make the example a little bit more complicated and more appropriate to what your problem was with your code, notice how on line 10 I define a list of room called connections. If I were to never instantiate my list of connections and I were to attempt to operate upon that list of connections, let's say I just want to say for each var room in connections room.hey. It doesn't matter what the code does. The fact is this method now acts upon this field. But the problem with this is connections is still null. It still exists nowhere. It doesn't have a home in memory, so it just stays nothing, and trying to operate upon this field whatsoever will point to null. And operating on null is invalid. So what I have to do, what I'm forced to do, is specify at some point that this connections field must be instantiated. There must be a place in memory to reserve this object, and I must reserve it so it has a place to live. So if I run this code, I'll get an error very similar to what you got before, a null reference exception. Object reference not set to an instance of an object. Whenever you see a null reference exception, you know that you haven't instantiated something. It's null. Operating on this object, operating on this field rather, sorry, because it's not an object yet, is invalid because this object, or this reference, doesn't have a place to live. However,
and actually, with you saying reserve so many times, it is just like reserving a restaurant table.
Yeah.
You can reserve it if you want. You can ring up and reserve the table, but that's not going to mean you can eat until you actually go there. Sorry, that was tenuous even for me, but it appeared in my head because you said reserve so many times.
Well, yeah, well, kind of. I mean, to put it, let's say there's a restaurant that requires reservations. You can't walk into that restaurant unless you've reserved a seat. If you do, you'll get kicked out. The waiters or whatever will give you a null reference exception and send you on your way. But if you do reserve your location in that restaurant, then you have a place to go when you want to operate upon that reservation. So now you'll notice by adding the connections equals new list, I have given this object, I've created an object, I've given it a home, and I've assigned it to my connections field. And by doing so, my code no longer errors out.
And because David asked, do we always have to use the new to remove a null reference exception? No. In this case, if you were actually just, can you put up the example of it breaking in the same way but with an integer?
There's no way. Integers are never null.
Or string, would that work?
Yeah, strings can be null. Well, but well, in the case of a string, my string.
Well, you know where I'm going. Put up an example that demonstrates what I'm just saying.
If I were to try to do this, I would get a null reference. Well, actually, never mind. Right line doesn't. If I were to do my string dot to lower, then I would get a null reference exception. And you'll notice I do. I get a null reference exception because string is null. One way that you can fix this is simply setting it to a string literal, because strings are a special case within the C# language, meaning that this, behind the scenes, does do... Well, actually doesn't. It points to a string table. But still, the point is...
It does the same thing.
It does a very similar
thing. Use the
thing.
new operator. But in general, you're going to, rather than saying you always have to use the new to remove one, you are going to always have to instantiate something. That is what the null reference exception means. You're trying to access something that you haven't instantiated yet. So either you'll need to do that. Most commonly, you will need to do what Nelson just did, which is add the actual initialization of it, or do the opposite, i.e., delete any references to it that you've made. If you've done that in error, and that you don't need.
Basically, null reference exceptions will happen in two instances. One instance when you didn't instantiate an object, you didn't use the new operator. And the other instance is going to be when you are expecting something to be passed into your method to be instantiated, but you don't instantiate it. Because you can still... It's like the case with your engine. If I had a class engine right here, and I wanted my room to have a reference to my engine, I can say private read-only engine all day long, and I can attempt to work upon this. So like, for example, console writeline engine.toString. I can attempt to work upon this field all I want, but it's not appropriate for me to instantiate the engine inside of the room constructor, because we only want one instance of the engine. We want as many instances of this list class as we need, but we only want one engine within our program. So to solve this problem, you wouldn't instantiate the engine from within the room constructor. Instead, you would pass it in as a parameter. So this forces, by doing what I just did, it forces whoever wants to build a room to provide a proper engine instantiation. That being said...
The thing is now, if you had any pre-extant calls to room, you would get an error.
Like on line 32.
But it would be a compiler error.
Yeah.
Yeah. But it's a compiler error. You've moved a runtime exception, bad thing, don't like bad thing, make crash.
Yeah.
You've turned that into a compile time error, which basically says, there's no point. You can't do this. You need to fix this.
Basically,
that is a good thing, because it tells the programmer that he's being a numpty.
Exactly.
Rather than telling the user that the programmer is being a numpty.
I like to think of my error list as a checklist of things that I need to fix before running it again. And I have to. There's no way around it. But thinking about it as a checklist of problems you have to solve is a good way to think about it. But you'll notice that, however, as a rule of thumb, any field that points to a object, any field that's a reference, inside of your class, you will do one of two things in the constructor for every field. You will either take that field in as a parameter, or you will instantiate that field from within the constructor.
And just to round that off, in this case, for example, you will still somewhere in code, whether it's your code or code that comes with .NET, there will be something that says engine equals new engine, in order to pass that into the exactly what Nelson just did. And that's that again. It guarantees that if, as far as the room class is concerned, the engine has to be given to it, or it will just say no, rather than hiding away and then blowing up in the face of a user. Barry had a good question ages ago, so I hope he's still here.
Don't want to answer. I mean, in the context.
Don't want to answer it.
Barry, the answer is yes. Or no, sorry, the answer is no.
Yeah, you don't have to
No.
do what you want. I was thinking that as well, but
just for in the case of this example,
for clarity,
that it's more clear in this example to do that. But no, you don't have to do both. But you can.
Yeah, but your reasoning was absolutely correct. How cool was that? That was cool. We've done that. Chris's question up here.
By the way, is there a difference between a structure and a class? That class is executable code. Are you talking about C++ or C#? Okay, in C++, there's only one difference between a class and a structure. A structure has the default accessibility of public, whereas a class has the default accessibility of private. That being said, the reason I chose to use structures in the examples is because so far we have been using structures as if we had no classes. In fact, the way that we've been using structures so far in the C++ course is exactly how a person would do object-oriented programming in C. I'm kind of trying to trick people into thinking in an object-oriented way before actually being introduced to the tools that C++ made to make working with object-oriented programming easier. That being said...
Which, of course, would be better for you to do if like 99% of the class hadn't done something previously about object-oriented programming. But it was a nice idea.
But yeah, anyway, the fact is, at the end of the day, there's no difference in a class and a structure other than default accessibility.
But that's in C++.
Yes, in C# there are vast differences between classes and structures. Okay, somebody did ask to do a quick sample of the linked list. I don't know if I should. I mean, I can.
This is, well, what do you mean by, I'm afraid I got overzealous in my ticking off and deleted that question. To be honest, I think in terms of homework, I mean, that's the current homework, is to work out how to implement it. And I think what you need to do, really, is get those videos up.
Yeah, I'm doing that right after class. Sorry, I can't encode videos while I'm recording. And as a result, I haven't been able to work anymore on the encoding tonight. And over the weekend, I was working on other encoding jobs. So
yeah, I was just because in the actual proper answer is we went about as far into that without actually giving the answer away between Monday and Friday's classes as we really should be.
Yeah, the thing about linked list is it's so important.
Radioactive. That's what I mean. We did actually. Nelson went into quite a bit more detail on Friday than on Monday.
I can do that again.
This is certainly,
I can certainly do that again. I won't do any more than what we've done on Friday, but because we don't have any other questions, it would at least save people.
Florin's just gisted something. That might.
What did I just do?
Florin, is that related to this? Are you gisting helpful code?
But yeah, I can go ahead and explain it again, just so you guys, the people watching this who haven't seen the Friday's class yet, don't have to go and watch that video, because I mean that is kind of mean. We have the time to go over it again. Okay, so a linked list is a data structure for storing 0 to as many elements as you want of data. So, for example, like you have a vector, which allows you to store 0 to many items, unlike an array, which may only store a fixed amount of items. A linked list is a different way about going about it. With a linked list, you'll typically start off with in this case, because we don't know what classes are yet, I want to start off with structs. And structs. So you'll typically start off with a struct called a node. What's a node? In a linked list, a node is typically going to be two things. The first thing it's going to be is it's going to be the piece of data. And I know that seems like a really ambiguous definition, but let's say you were creating a linked list for doubles, like what the homework calls for. I don't think it calls for it explicitly, but I'm sure most people are ending up using doubles for this. But you'll have
It would be a datum.
You'll have a data.
A datum.
Yeah, datum. And the reason I have this boxed is this is not valid code. But if you wanted every node to have a string, you would do like string value. If you wanted doubles, you'd be doing double value. If you wanted ints, you'd be doing int value. If you wanted, or you could have all of these. Well, yeah, change the name, value 1, value 2, value 3, doesn't matter. The fact is, the struct node will contain whatever data you want for every individual element of your data structure. The next most important thing that a structure contains is a node pointer. Now we did have called next. Now, we did have some person ask a good question on Friday, though, that I want to repeat here. They asked, wouldn't this cause an infinite loop? The answer would be yes if this wasn't a node pointer. Because this is a node pointer, however, remember that a node pointer
is a pointer, not a node.
So all this is on a 32-bit, or at least compiled for a 32-bit architecture, is going to be 4 bytes. It's not going to be a fully functional other node in it. It's just going to be a node pointer. So you're allowed to do this. This won't cause the universe to implode. This is the only structure you need in order to create a linked list. Because what you'll end up doing in memory is something like this. Well, let's back up a second, actually. Let's talk about vectors. A vector, so this is a memory for a vector. A vector is a contiguous block of memory, just like an array, where every element that is in the vector is a distinct piece of that contiguous block. And if you...
Can you say the same for a C# list?
Yes, same things for a C# list. However, the problem is once you fill up every single item out of this vector, in order to add a new item to it, you have to completely delete the old memory and create a new contiguous block of memory that's one item larger. So this is the memory for a vector. The memory for a linked list is the fundamental difference between a linked list and a vector and an array. The memory for a linked list looks like this. You'll start off with a variety of nodes. So here's a node. Actually, that's too big. Here's a node. Here is additional memory. Now, when I say ... what I'm meaning is, what I'm trying to express is the fact that linked lists do not need to be contiguous. Unlike vectors...
You should just put boxes all over the screen, rather than in a big column for linked list. I thought you should do this the other day. It's just little bits of memory.
Well, I didn't want to... I mean, I guess I can, but they need to be differentiated somehow. Let me change the color. Actually, I'm going to... Red. 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 Okay, so you might have a red box here, so that's another node, and then you might have some more memory down here that has nothing to do with the linked list. Then you might have another linked list node, or maybe two in a row, it doesn't matter, and then some further additional non-congruent memory, and then finally at the end you might have a linked list node at the end of your memory. Each one of these red boxes represents a linked list node. They both contain two things. So this is node 1, this is node 2. Actually, what I'm going to do is I'm going to say this is node 1, and you'll see why I moved it in a second.
Oh, wow.
Okay, this is memory address 0x01. This is memory address 0x02. This is memory address 0x... I'm not even going to do the 0x anymore. You know what? I'm just going to do decimal. 01, 02, 03, 04, 05, 06, 07, 08, 09, 10, 11.
You were that close to 010 then.
Okay, so each one of these boxes is an address in memory, and I know this isn't technically correct, but it will serve for the purposes of the explanation. Now, each one of these linked list nodes contain two things. They contain the data, which I'm going to represent with the D. The D means the data that the linked list contains. But they also have, each linked list node, but they also have something else that's even more important. They have a pointer called next that is going to be an address to the next linked list node. So, for example, on memory address 02, the next pointer is going to be 06. That's where the next pointer is going to contain. That's the address of the pointer. The address of this next pointer is going to be 07. The address of this pointer is going to be 11. Now, here's where things get crazy. Let me go ahead and do that, and do that, and do that. And give me my stuff. Give it to me. All of it. Oh, come on. That's a sick joke.
Fantastic.
Oh, no, I need my red back. I should have added to it. I think I just did that. I don't care. Okay, this pointer, this next pointer points to null, because it's at the end of the list.
And for a singly linked list, that is literally... That's all that happens with it. The key thing being the difference in what happens when you want to add something.
Yep. So let's say that... No. There we go. Let's say that we have a few more boxes. So we have some additional memory. We have a 12 and a 13. Let's say we want to add a new element to our linked list. Well, here's what we would do. The first thing we would do is we would instantiate a new node. So here's a new node being instantiated. And this is going to be memory address 14. Then what we're going to do is we're going to set, instead of having the next pointer here, well, we're going to set the data first. So there's the piece of data that this linked list item contains. Then we're going to set the next pointer of the last node to the address of the new node. So this becomes 14. No new memory other than the linked list node needs to be allocated. The only memory that needs to be allocated is this new node on address 14.
Just for clarity, if you just tabulate it like you did the other day with a node and its address and the next value is columns.
Yeah. Actually, how did I fail doing that? Ah! I should have created a different layer for this. I don't know why I was so stupid. Because now, as a result, every time I try... What? Well, I can't now. I'll just...
Never mind.
I'm going to go ahead and create a new layer. So now when I delete, I'll be able to have two colors that I want on my stupid thing. There we go. Okay, so here's the address. Here's the value. Here's the next pointer. The address of the node, the value that the node contains, and the pointer to the next item. So in this case, to follow along with this so it doesn't get confusing, the first node that we have is at address 02. And let's pretend that each one of these nodes contains an integer. So the data right here is an integer. So the value is going to be here, let's say 10. The next pointer is going to be 0, 6. The next node in the list has an address of 0, 6, a value of, let's say, 20, and a next pointer of 0, 7. This item will have an address of 0, 7, a value of 5, and a next pointer of 11. This will have an address of 11, a value of 7, I guess, and a next pointer to 14. The element on 14, however, on address 14, might have a value of 20 again, but the next pointer is going to be null, signaling the end of the list. The only thing we need in order to operate on a linked list is a pointer to the first node. Because given a pointer to the first node, we can traverse the linked list by going to the next pointer. So the next pointer goes here, and then that goes here, and then that goes there, and so on, so on. There's a way to automate node creation and linking. The way I'm thinking of doing it, you have to manually create a new node, set its data, and set the previous node's next node to new node. You could create a function. Let's say you had a function with a signature like this. Void add item node pointer fst comma int val. This method signature is the only bit of data that you need in order to add an item to a linked list. You would walk up the linked list by using the first pointer, and then you would instantiate a new node, set the set the last node's next value to the new node, and then set the new node's value to whatever you passed in as a parameter.
Because remember, the value null is a big stop sign saying it can be interpreted as I am the last member in the list. If my pointer is null, I'm the last member of the list.
Yep. Yeah, I highly encourage people to draw this out themselves. When working with algorithms and data structures, drawing things out is very helpful. But Alan, was this a comprehensive enough overview of a linked list? Because I really want to see people, given the information that we provided, I really want to see people, as a really good exercise, translate this into code. Because that's all programming really is. It's the translation of an idea, of an algorithm, of a data structure, into, in the cases of either C++ or C#, procedural code. Well, typically, I mean, you have object-oriented code, then you have functional code, and you have dynamic code.
But have a full stop.
We've been working completely procedurally in C++ up until this point.
And just in case, like Googling or Wikipedia-izing, that's really not a word, but you come across reference, this would be termed a singly linked list.
Yes. There's also such a thing as a doubly linked list, and which you can implement for fun if you wish.
And it's no more difficult to implement. You can probably guess what extra. Yeah. It has one extra thing about it.
I'll give you a hint. Instead of an N in there, it'll be a P.
Indeed, and to give you another hint, that will enable you to
go backwards.
Well, do a variety of things. Yes, go backwards. I was going to say delete, but that gets into the whole thing. But at the moment, it's a big pain. But
and adding an item to the end of a doubly linked list is going to be faster, at least if you carry around a reference to the last node and the first node. But that's not the point of the exercise. The point of the exercise is to familiarize people with the concept of pointers, because this, by definition, requires an understanding of pointers and dynamic memory allocation.
And by the way, seeing as you just reposted it, don't bring Florin's post onto the screen.
Yeah, I did keep it open
because it's an answer to the
right.
To this. Logistic question from NATO in Bosnia.
No, so not sure possible, but you can reduce the amount of time I have to wait before sending PMs. I don't know if I can.
Yeah.
Well, I can.
So
I'm an admin, but
somebody
I've
can.
never tried to do it before, and I hate the vBulletin admin panel. It makes me cry. But I'll go into it and see if I can. Well, I know I can, but I'll go in and beat my head against it.
See if you can remember where.
Yeah.
Have you seen the size of my PM box, by the way?
Isn't it like 10,000 or something?
It's 20,000.
All
I seem
right.
to remember there was a time when there were about half a dozen things that I'd bugged Zach about, or that Zach had been bugged to do when setting me up to do extra stuff, and he just went, "Oh, for God's sake!"
All right. I'm going to go ahead and hit pause.
If you're interested in this stuff, you know.
Yeah, that's definitely.
That's kind of the thing. If you're interested in being a programmer, welcome to programming. This is essentially, I mean, and it kind of struck me quite hard, so which is why I keep mentioning it. But at some point, somebody had to write a linked list. Somebody had to write it, otherwise it wouldn't exist. So somebody somewhere has had to sit down and go through this exact process.
Mm-hmm.
And because they're the fundamental building block, it really gives you, trying to write something is always the best way, or 90% of the time is the best way of understanding how it really works. And where the kind of, again, the gotchas are in it. You might think you have a vague understanding of how it works until you try to code something up. And you suddenly realize, oh, actually that's more complicated than I thought it would be, or, oh, actually if I do this, everything else is easier.
Okay. James asks, can I use equals 0 to check for a null reference pointer? Is this a C++ question or a C# question? Well, the answer for both C++ and C# is no. You can do it in C++. It is possible to do it in C++. Now, it's not possible to do it in C#, but it's possible to do it in C++. However, it is very bad practice to treat a null pointer as the integral value of 0. And the reasoning is, well, I mean...
Well, 0 is a thing.
Yeah, 0 is a thing. That's the first reason. Second of all, you are at that point treating a pointer like a number, which is silly. And third of all, per the specification, to create standard compliant C++ code that has the best chance to compile on all compilers. And the reason I say best chance is because writing cross-compiling C++ code on a production application will pretty much force you to choose what you want things to compile on, and then every night have your build system build your code out for everything, because there's always tiny gotchas. But the C++ standard does not specify that null be 0. As a result, it is theoretically possible to work with a compiler that doesn't define null as 0, and as a result, your code will not compile against the architecture properly. The null value is almost always defined as 0, almost always, but it's not specified to be.
And I'd like to use that as an opportunity to slap Musaru, but just for, tradition, or an old charter or something. Well, he was complaining the other day that I didn't, so I thought I would. Who you call it? No.
Okay. And if I put those functions into the struct itself to make the code feel more C-sharpish, if you want to play around with that, with putting functions inside of structures, you're more than welcome to. But next week is going to be focused entirely on object-oriented programming. What I wanted, again, here's the issue. The fact is, when I created the syllabus, I did some things for very specific reasons, and
those reasons were dumb.
I was approaching it from the perspective of a person who hadn't programmed before, because that's what the course is designed for. And as a result, the way I organized, particularly the last 3 homeworks, weren't an accident. I really wanted to lead people into thinking in terms of object-oriented programming without even realizing it. and then turning around and being able to say, oh yeah, you know the code that you now understand using this style of programming? Well, here's a feature in the language that makes that style of programming a lot easier. So you're more than welcome to, but I want people to think in terms of object-oriented programming, but by accident. And then when we introduce classes, it won't be like a, why would I ever use this? Which is the number one question I get from anybody learning a new feature of a language.
Every single feature somebody has asked, why would I ever want to do this? You will. You'll want to use this in the situations where you go, oh, you know what? That thing that I know about, that would be really useful to use. That's the situation in which you will use it. I don't know. It is though. I mean, and I did it myself when I was starting out. You know, why would I do it this way when I've so happily written out everything longhand before? You just, when it kind of is like that, it's, if your question is why to do something, there's probably a better question related to it, in which is what, you know, I don't know. It makes it's just an odd question to me now. But as I say, you go through that phase.
Yep. And so that's why I architected the homework in a specific way, because of object-oriented programming. And I'm sorry to all the people who already knew object-oriented programming who had to suffer through it. But I mean, hopefully, even you guys who do know object-oriented programming are gaining a better appreciation for it as well.
Well, and I've said this a number of times. You get a much clearer appreciation of what's going on in C++ because it smacks you in the face with what is going on. You actually have to deal with all this stuff. C# is a bit like an overprotective parent, really. Particularly with ReSharper is like the social services. It will not let you. It'll just say, "Oh look, I'll do it for you." Whereas in C++, it just says, "Nope, get on with it," which is better for learning.
Yeah, and and C++ is so bare metal, whereas C# is hidden behind layers of abstraction. Those abstractions become so much more useful to you once you understand what those abstractions are. And the fact is, all those people who are in the C++ class who were new to programming and did the C# 101, I hope that people have been learning about dynamic memory allocation, even if they're never going to be using, even if they're never going to use C++ for a production application. I hope that the people who went through the 101, C# 101, then went into the C++ 101, now know the magic behind the new keyword. What happens every time you type in new, and that you notice the complete lack of a delete keyword. C# does not have a delete keyword. Well, it doesn't, but C# actually does have pointers. By the way, I feel like pointing this out. It's called unsafe code. You have to explicitly compile with a special compiler flag and mark every method that uses a pointer with the unsafe tag. And it requires, the permissions required to run your application are really, really strict. But you can have pointers in C#, which I always thought was funny. Never done that in production code, but I've toyed around with it a while. It's kind of fun.
And Radioactive, was it you that the other day, were you in Friday's class? I can't recall.
My tablet is just freaking out. It is inserting brackets into
Are you a Friday guy or a Monday guy? Oh, C# Thursday. I see.
Well, yeah, and it's funny that he brings up the opposite. Because he said that he's getting a better eye for object-oriented programming, and if he's only doing the C# stuff, he's doing the complete opposite. You know, people in the C++ are getting a better perspective of low-level concepts and what the abstractions actually do behind the scenes. But then again, the C# class is going into some really intense object-oriented design, which can be applied to any language. You can apply object-oriented design to C. Now, you would have a very painful time doing so, but you can, because you have all the tools to express object orientation. It's just
To be
that,
fair, I think most people should probably apply it to life.
yeah.
The world would be a lot easier to get through if people had some logic to them. Not that I'm bitter at all.
Does it then run faster? Florin, I just noticed your question 2 minutes ago, so I can't remember exactly what that was in context of. Sorry.
What
The
time's
C
the
sharp
UK
unsafe.
class, Chris?
There's some things that you can do with the C sharp unsafe context that particularly give you a little bit more control over memory, and do provide some levels of optimization you can do in terms of memory and dynamic memory allocation. Other than that, the fact that you have to decorate your code with the unsafe keyword, set a special compiler flag, and introduce all the potential problems that you have with C++ pointers, it's typically not worth it unless you know exactly what you're doing. And I've built applications that had not game engine. I don't mean game. I mean game engine performance constraints, at least professionally. But I have worked on plenty of C# applications that needed to perform well, and have never found myself reaching to C# pointers to solve a performance issue.
Is it? I was going to say, is it largely nowadays used for like wrappers around something that you've brought in some legacy C++ code or something?
Sometimes
A wrap around a C++ DLL or...
See, there is an int PTR type in C# or in .NET that has compatibility with native pointers. You can't act upon it, but you can use it to represent pointers. So even in the case where you are doing interrupt with lower level platforms, you
still wouldn't use
it. You would pass an int PTR from one low level function into another low level function. Okay.
Well, I think we're probably about there, really. We have gone somewhat into...
Well, yeah, I'm just trying to entertain people.
Conceptual areas. No, it's it's an interesting discussion and helpful, I think. But it's entirely possible we could sit here and talk about this for hours.
Yeah.
Because it's more into conceptual ideas of coding.
Yeah, so I think I'm going to go ahead and hit the stop button. So to all the people watching this, I hope you guys learned something. Goodbye.
Goodbye.